Computer Cutsy, CASTLEGAR, British Columbia, runway 33. We will take off, head northeast, and return immediately for an RNAV GNSS Alpha. Circle to land, runway 33. This airport has virtually no nav aids or any way or means to do an approach other than a visual approach following Jefferson's chart. In other words, once down to minimum runway in sight, everything is virtually by the seat of your pants, so to speak. In 1985, I changed that through my company Lat Long Inc. and copyrighted in 1990, and on December the 4th, the system logic for line selectable FMS approaches. That's what we're going to view now. We've been given takeoff clearance off runway 33 with a northeast departure. 40% EGT rollback. N1 Toga.
knots.
Okay.
V1 rotate. Positive rate.
Gear up. LNAV.
400.
Command. LNAV
1000.
speed. Power. One. Pops up. Flaps up, lights out. Altitude, climbing is 9,000. Land elevation set, so air conditioning bleeds and packs. Set. Operating. Flaps up, lights out. Landing gear lever up. I should say auto brakes would go off at this point first, and then the landing gear lever up and off. But because we're coming right back, we're going to set
As we go.
position 4 check. 1,000 to level off, 8 for 9,000 feet. FMC speed, 8.5 pounds. Weather's clear. We're going to set a minimum on the MCP. The minimum actually published is 4380 plus 50 feet is 4430 rounded up. The next 100 level would be 4500 on the MCP. So that's what we're setting now. we'll actually set the minimum also at this time. $43.80. Set. We'll bring our speed back to flaps up speed as we are going to begin slowing for this approach. We're going directly into the approach. We haven't cleared the RNAV, should say the RNAV GNSS Alpha to run to the airport. We're going to circle to land on the west side. Circling is not allowed to the east side, and land on runway 33. We'll configure for landing at 2 nautical miles prior to top of descent. Now we'll start slowing. Flaps 1. Flaps 1 speed set. Flaps 5. Flaps 5 speed set. Sharing with you a screen that I use in an online the FMCC review, the first officer's nav display, upper ICAS, lower ICAS is behind my picture, it's blank right now, and PowerPoint that we created at Long Global, more than 800 for tutoring. This is the first officer's PFD and the standby PFD. Back to the main screen. Set the bank at 30 because of tight turns required and the minimum radius turn required if we need it later on in the descent. Follow your company SOPs.
$2,500.
Heck, pretty well altimeter alive, and it is. VNAV path, FMC speed, that's what we want. And the speed jumped up to back in the software. It'll be a flaps 5 with flap 5 speed set. We'll start configuring 2 nautical miles before top of descent. Long Global pad an important hand, so to speak, in the formation of line selectable FMS approaches. And copyrighted
2,500.
check, radio altimeter alive. There's the BSD and there's the reason why. Copyrighted the logic behind all FMS approaches on December the 4th, 1990. A license is required to use the FMS. The license has to be purchased from Lat Long Global. 2160 and 40, we're monitoring the radio altimeter closely. That's 15 speed set. That's 40. We're at 40 plus 5. Set. Brakes arm. We've set a lower altitude. Now we'll go up to the MCP and actually set to 100 feet above the airport altitude. Set. Descent approach procedures. Descent approach checklist complete. Landing procedure and checklist not complete yet. We haven't set the missed approach altitude, which is 8,800. We'll do that later. There's a poppy on RWY33 set at 2.9 degrees. Our plan, because of terrain, is to be wings level close to 300 feet on final, on the line on a 2.9 degree poppy. That's what we're planning. You can see the terrain here in front of us. It's really quite something. And we'll pop over to another screen, share that with you so you can see. Here we are here. That's our aircraft position and on track and just going by the waypoint Eplet, and it looks good. Back to the flight deck. We've left 9,000, currently leaving 8,300 feet for minimum of 4,380 with a continuation down, providing we are happy and we are going to land. We'll make our decision at that point. Looking good here with the RNP 400 and AMP at 0.50 for this area. So we're LNAV and VNAV. FMC speed, LNAV and VNAV path. Leaving 8,000 feet for a minimum of close to the threshold height of 1626 for RWY33 at CASTLEGAR. Our minimum actually for the approach is 4,380. We've set that, and if we decide that we're going to continue to land, then we'll land. Otherwise, we'll carry out the missed approach procedure. All right, this is the demo, and this is what we can do for you. and the importance to have this in a database as line selectable. There's our NPS, Nav Performance Scale, vertical path, and this is our lateral path that we're on, and looking good. Most aircraft that fly into this airport have a much lower true airspeed than the Boeing 737. Around 84 knots true airspeed. So tighter radius turns can be accomplished. And we can design a tighter pattern, line selectable, for runway 33 and for runway 15. What you're going to do today is an aircraft with a true airspeed that's quite a bit higher than, say, a Dash 7. Let's go and set the scale down to a minimum scale so we can better appreciate. Go back, adjust our heading bug. There we go. There we are on the path. Back to the flight deck. Good rate of descent, as you notice. Arm, in-app speed, in order to make good. This symbol here is because of our pitch being, say, pitch down at 8 degrees below the horizon. That'll change as the rate of descent changes and we intersect the vertical path. So that's what we're doing here. Notice on the VSD. And when we do intercept the vertical path, we're presently 1,300 feet high. And as soon as we're within 400 feet, the NPS scale will start moving, and when we're on path, it'll move to perfectly on path. 5,000 feet in the descent to minimum for decision making of 4380. We're sharing the main computer screen here now, in the simulator I should say, with the heads-up display. We can see the airport environment here, we can actually see the runway. So minimum.
2,500.
Radio altimeter alive. And it's
Minimum.
Because of this, we have here FMC speed being at FAB. 2320, 2320. We're going to hear many messages in the base leg turn, and we're going to be visual, and provided we accept that we're safe, we can disregard those messages, but they have to be spoken about and agreed upon between pilot flying and pilot monitoring. Just preparing you for what we're going to hear because of the terrain. Here's the airport here, and there's runway 33. We're going to proceed to the west side, circle to land over this high terrain here, and intercept 2.9 copy.
1,000.
Check.
1,000 feet stabilized missing approach.
Disregard that
500.
because we're visual and we're looking good. So we're disregarding and we agree on that, but we don't have to. That's because of this terrain here. And we have good clearance. There is the runway here. All right. Things happen fast, and this is an important maneuver and should be line selectable from the database. That's what we, Lat Long Global, are all about. We're coming up over the field. Below us, we can see
Terrain.
it. Okay, we check.
Terrain.
We can disregard. Here it is here. Disregard because we're happy with what we see and where we are.
Terrain.
So the GPWS system
Terrain.
is doing its job, but we have to
Terrain.
do our job also. There it is in front
Terrain.
of us, and we're not going to go
Terrain.
into that. We're going to be turning before that.
Terrain.
Check.
Terrain.
1200 on the radio altimeter.
Terrain.
We're looking good.
Terrain.
So we agree that we can
Terrain.
1,000.
disregard that.
1,000 feet
Here is
stabilized
the
missing
Terrain.
approach altitude.
Terrain.
Disregard
Up.
that because We'll
Terrain.
disregard that
Terrain.
because we
Pull
are
up.
clear of terrain
Terrain.
and looking good.
Terrain.
We can disregard
Pull up.
that. In the
500.
turn,